So because this is an online class, I thought I'd just go ahead and pull this up real quick. There are a couple of these in the homework where they talk about finding the domain, and and it's slightly different than what we mean. They're natural log. We didn't do natural logs in the previous video when we're graphing and look at transformations. And so it's like, well, how would you do this? Well, with your graphing calculator, So if you wanted to be able to tell the domain of this guy, the cool thing about a graphing calculator is that you can graph things and see what it looks like. So we would do the ln, which is down at the bottom left. I would do my fraction key. So I'm going to choose alpha y equals number 1. And then I've got my 1 on top. And I have my x plus 2 on the bottom. I arrow out, close it off, I hit graph. So now I have a picture here. And I'm going to pull this picture off here so I can write on a little bit and help you visualize what's going on here. This guy has an asymptote, and what I'm hoping is that you see in this particular situation is I'm hoping that you see that this graph continues on an asymptote. Now, because of the graphics of this calculator, it doesn't show you everything you need, but what's happening here is this graph's going to turn the corner. It's going to keep coming up, up, up. Now, I know that that's going to keep coming up, up, up right there because I know there's an asymptote. Well, you might say, well, how do you know there's an asymptote? Not a very good line. How do you know that there is an asymptote right here, Mr. Fix? Well, because of the 2. I know that there's an asymptote because of the 2, because of this right here. I know that mathematically that this is the same thing as me saying the ln of x plus 2 to the negative 1. So I know that essentially what I have right here is I have a reflection. I have a reflection over the x-axis. So essentially now I can see my parentheses, and so hopefully what you're saying is that this is like saying x plus h. And so your h value moves you left or right. Since this is positive 2, we don't move positive 2, we move to the left 2. So this is a transformation to the left 2 times, and it also has a reflection, but that's besides the point. We can see the transformation. So in my parent function would have come up something like this, turned the corner and gone out, and so I would have had an asymptote at x equals 0. There would have been that dotted line right there at x equals 0. So that's moved over 2 times because of the 2. Now, if we go back to our calculator, we can see that by going to our table. And what you can see is in your table is that when you get to negative 2, so here we are, we're cruising along, we're at 0, negative 1, negative 1, I might have drawn that wrong, it's okay. Negative 1, negative 2, and so you can see here when you get to negative 2, it's an error. Well, that's what an asymptote looks like. When your calculator tells you error, that means you're not going any further. So we saw earlier, it gave you the number again and again and again and again, an exponential. In logarithmic, it gives you an error because you're never going to cross over. You can't plug negative 4 in. You can't plug negative 5 in. It gives you an error message. It will not work. All right? And the reason is because you cannot take the natural log or the log of a negative. So same thing, won't go any further than this, but we got the second one right here. We should be able to see this is going to be a transformation to the left 8 times, but we type it in just to see. So we got x plus 8. Oh, I never even got to the answer. So that means my asymptote is at, not y, but at x equals negative 2. That means that my domain starts at negative 2 and goes to infinity. On the next one, we type that in, we hit graph, and hopefully what you can see is it's been shifted over 8 times. So we go to our table just to confirm that asymptote thing. So look what happens at negative 8. So you can see at negative 8 you've got that asymptote, and so let's go back to the graph, we'll grab this, pull it off, make it a little bit bigger here. So because of that 8 right there, and because we know how asymptotes behave, we know that this graph is going to come down and turn the corner like this. And so there's 1, 2, 3, 4, 5, 6, 7, 8. And so I have this vertical asymptote at negative 8. Sorry about that. It's not drawn very well, but you get the idea. Okay? And so we can say that our domain, since our asymptote is at x equals -8, then our domain goes from -8 to infinity. Okay, so that's how you would find the domain if we didn't ask you to do all the other stuff, is we just go to our calculator and we learn how to read that stuff, which we've been doing all semester, right? All right, last video, 4.4.